We're talking today about Pythagorean theorem. Pythagorean theorem has to do with right triangles and the length of their sides. In order to be able to do Pythagorean theorem, you're going to have to identify that it is a right triangle, and of course a right triangle has a 90-degree angle for one of its angles. So this theorem is used to find the missing length of any side of the triangle as long as you know the other two sides. It does not work with any other type of triangle except for a right triangle. We're going to take a look at the parts of a triangle, and the longest side of a triangle is called the hypotenuse, which is opposite from the right angle. And then the two other sides, the shorter sides, are the legs. The legs can be found by locating the 90-degree box, the box that indicates which angle is 90 degrees, and then the box holds onto the two legs of a right triangle. So we call these legs A and B, and it doesn't matter which leg is marked A and which leg is marked B. But most people make A the shortest side and B the middle length side. Let's take a look at something here. Here is a triangle. If we're going to label the hypotenuse, it is the longest side of the triangle and it is opposite from the 90-degree angle. So obviously when we're looking at this particular item, our hypotenuse is going to be the long side of our triangle, which is here. Okay, and then it's the diagonal, in other words. Its measurement is always the longest side of the triangle. And the two legs form the right angle at the bottom corner. So normally we would label this one A, is the shorter one, and B for the medium one. Usually the height is B, and they call this the altitude, would be A. Okay. The Pythagorean theorem now states that if you add the squares of your two legs together, it will be equal to the square of the hypotenuse. Usually this is shown as a squared plus b squared equals c squared, where a and b are always the legs and c is always the hypotenuse. So in other words, when we're looking at our right triangle, pardon me as my pen doesn't work 100% great. All right, we're looking at the little right angle mark down here. We would have A, B, and C. Okay, A squared, let's say this was 3. B squared, we need to find out what C is. So 3 squared is 9. 4 squared is 16. A squared plus B squared equals C squared. Right? If A is 3 squared and B is 4 squared, what is C squared going to be? This is 9 plus 16 equals C squared. Let me move this out of the way real quick. All right. There we go. And still going to be C squared here. 9 plus 16 is 25. So 25 is equal to C squared. So what will C be? C is the square root of 25, which is 5. So this side would be worth 5. All right, let's take a look at this a little bit more in depth. You can watch a video on YouTube at the address at the bottom of your screen here, if you would like to pull that up. It explains a little bit more about Pythagorean theorem, and we are going to do some practice problems on Pythagorean theorem. So let's determine whether these triangles, the side lengths of these triangles, would make a right triangle or not. So if the Pythagorean theorem holds true, then these measurements, short, middle, long, A, B, C, will give us A squared plus B squared equal to C squared. So looking at your item here, and you can use a calculator to figure this out. What we would have here with a squared plus b squared equals c squared, this is the short side a, middle b, long c. Now we're going to fill these numbers into our a squared plus b squared equals c squared. So this would be 12 squared plus 16 squared equals 20 squared. We're going to find out if this is true or not. If this turns out to be true, then we know for sure we have a right triangle with these three measurements. So let's look at this. 12 squared is 144. 16 squared, remember that 16 times 16 is 256. And 20 squared is 400. That's 20 times 20. Add these two together. It actually does make 400. So now I have 400 on both sides of my equation. They're equal. That means this is a right triangle. Okay, let's take a look at set 2. A is short, B is middle, C is long. A squared plus B squared equals C squared. So A, this would be 5 squared. B will be 10 squared. C is 15 squared. So 5 squared is 25. That's 5 times 5. 10 squared is 100. And 15 squared is 225. Add A and B together. A squared and B squared together make 125. This does not equal, and so an equal sign with a line through it means does not equal 225, so this is not a right triangle. Okay, that's going to be one of the things you're going to be asked to do on your homework, is to tell me whether measurements make a right triangle or not. Let's take a look at using what we know about squares and square roots and the Pythagorean theorem to solve the problems here for the length of the missing side. In this case, it's C. We're looking for C in all of these. So remember, we're using A squared plus B squared equals C squared. We can label our triangles A, B, and C. So A squared will be 6 squared plus B squared, that's 8 squared, will be equal to C squared. 6 squared is 36. 8 squared, 64. This is going to be equal to C squared. We're going to add these together. We get 100 equals C squared. Okay, 100 does not equal C, which is the side length. 100 is C squared. So now we have to back up and find out what number can we multiply together to give us 100, and that'll be the square root here. So the square root of 100, you all know that 10 times 10 is 100. So 10 is C. So this is 10 up here. All right. Same thing for the next one. 7 squared plus 10 squared equals C squared. Remember, we've got the short side is A, middle side is B, long side is C. 49 plus 100 equals C squared. Okay. Now we look at 149 equals C squared. How are we going to find C? We're going to take the square root of C squared. That'll give us C over here. And the square root of 149, we're going to have to estimate that out. So we know that 144 would be 12 squared. That's pretty close. And then 13 squared is 169, so that's a little farther away. So about 12. I'm going to put the little wavy line that means about here. So about 12 for the side, the hypotenuse on this second triangle. All right, so Mr. Thompson created a mosaic tile in the shape of a square to place in his kitchen. What is the closest to the length of the diagonal of the tile. So we need to find out what the diagonal of this tile is. We're going to split it into two triangles, and it's a square tile, so one angle of our triangle will be a 90-degree angle here in the corner. So now we have sides of 9 inches and 9 inches. It doesn't matter which one gets labeled A or B in this case. So now we have A, B, and C. So now we have a squared plus b squared equals c squared. That gives us 9 squared plus 9 squared equals c squared. 81 plus 81 equals c squared. All right. 162 equals c squared. Now we have to find the square root of both sides to find out what c is. C will be equal to, and it's going to come close to 13 on this case. Remember that 13 times 13 is 169. So we're pretty close to 13 on this square root. So we're going to say approximately 13 inches, which will be letter B. Another example, if we're not even looking for the hypotenuse, how are we going to figure this out? So how can we use our formula to figure out what side B is in this case? So we're looking at side A, side B, and side C here. If we start with our regular formula, a squared plus b squared equals c squared, now we're going to have to do a little bit of equation solving to figure out what side B is going to be worth. We know it's a right triangle, so b squared plus a squared has to equal c squared here. A is 9, so 9 squared plus b squared, we don't know what that is, equals 15 squared, which is 225. Okay, now 9 squared is 81 plus b squared equals 225. Okay, so when we're looking at this, remembering how to solve an equation, we need to get our variable by itself. So we want b squared to be by itself. We have to get rid of the positive 81. Let's subtract it away. Okay, this cancels each other out. A positive and a negative makes 0. B squared equals 144. So now we're going to look for the square root of b squared. That will be b. And the square root of 144, which is 12. So side B here is equal to 12 in this case. Here's another one where we were given a composite figure. That's a square and a triangle together, and we're trying to figure out what this little section is. If we put this dotted line here that kind of cuts this into a square and a triangle, we know that all the sides of a square, and you can see that it's got the congruent marks here. You've got at least 3 congruent sides. That means the fourth is going to have to be congruent. So we know that this side is also worth 8 inches on that side. All right, so now we have A here, B here, and C there. We need to figure out what A is in this instance. That's going to be A squared plus B squared is going to be 8 squared plus C squared is going to be 10 squared. Oops, that's equal to A squared plus B squared equals C squared. Keep our A squared, we don't know what that is, plus 64 equals 100. We're going to solve. We have a positive 64 next to our variable. We're going to remove that with its opposite, negative 64. Positive and negative 64 make 0. That leaves us with a squared equals 36. The square root of a squared equals the square root of 36. All right. The square root of a squared is a. A times a is a squared. And the square root of 36 is 6. So the side length here is 6 inches. We'll do one more example. How far up a wall will an 11-meter ladder reach if the foot of the ladder must be 4 meters from the base of a wall? So we'd have to draw a picture of this if we didn't already have a picture. And we know that we've got 4 meters here at the bottom. The ladder is 11 meters long and it's resting up against the wall. And then we're trying to figure out how far up will that reach. So if I have the base of my ladder 4 meters out from the wall so that it's nice and stable, and my ladder's 11 meters long, how far up on that wall can I reach? So let's take a look. We're going to label A, B, and C. This is going to be my A. This will be my B. This is my C. So now I'm looking for B here. So I'm going to do A squared, which is going to be 4 squared, plus my B squared will equal 11 squared for C squared. I know that 4 times 4 is 16, plus B squared, and 11 times 11 is 121. Now I'm going to subtract away that 16 that's with my variable. This is going to cancel. Positive and negative 16 make 0. B squared equals 121 minus 16. So this will be a 5, 105. So now we're looking for the square root of 105. So the square root of B squared equals the square root of 105. We've got the square root of B squared is B because B times B is B squared. And the square root of 105 falls probably closest to 10. 10 times 10 is 100. 11 times 11 is 121. So this is closer or approximately 10 meters here.